In this video, I'm going to be discussing complex numbers. Now, complex numbers are written in the form a plus bi, where a is a real value and bi is an imaginary value. Now, you can do different operations with complex numbers just as you can with real numbers. So, for instance, you can add and subtract complex numbers. It's like combining like terms. So 4 plus 7 gives me 11. I plus negative 5i gives me negative 4i. With subtraction, it's the same thing. But be careful, if you're subtracting a negative, you're really just adding. So what you might consider doing is distributing a negative 1 into this complex number and losing the parentheses. So it would look like this. And if you do it this way, you do not have to worry about missing double negatives. So 7 minus 14 gives you negative 7. Negative 2 plus negative 2i plus 1i gives you negative 1i. So adding and subtracting complex numbers is like combining like terms. Now you can also multiply complex numbers, and for the most part, again, you can treat it like the I was an X. The only thing you have to worry about is if you get I to any power, you're going to get I squared a lot, and I squared is equal to negative 1. So for instance, this one I'm going to distribute. So 2i times 8 gives me negative 16i. 2i times negative 3i is negative 6i squared. But I'm not done here, because anytime you have I raised to any exponent, you can simplify. In this case, I squared is equal to negative 1. So that's the same thing as saying it's negative 6 times negative 1, which is positive 6. So my answer is positive 6 minus 16i. Or plus 16i. I'm so sorry. Sorry, I don't know where I imagined a negative there, but it's plus 16i. Now, if you have a binomial times a binomial, you're going to have to FOIL. FOIL stands for first, outside, inside, and last. So I'm going to multiply my first terms to get 28, my outside terms to get negative 7i, inside terms to give me 4i, and the last terms to get negative I squared. And now we simplify. So 28, I can combine these two to get negative 3i, and this is really minus negative 1, which of course means I'm adding 1. So the final answer would be 29 minus 3i. Now if you have one like this where it's squared, remember that it means you're multiplying the binomial by itself. And you're going to FOIL on this one too, or you can use what I call the box method. With the box method, you draw a square that you divide into 4, and your terms of each binomial go across the top and the side, like this. And then you multiply together. 6 times 6 is 36, 6 times negative 2i is negative 12i, multiply here and you get negative 12i again, multiply here and you get positive 4i squared. It does the same thing as FOIL, it's just another way of visualizing it. So now I'm going to go and combine like terms. I've got 36 here, negative 12i give me negative 24i, and 4i squared is equal to negative 4, because remember I squared is negative 1, so 4 times negative 1 is negative 4, which means the final solution on this one is 32 minus 24i. Now, there's something called a complex conjugate, which are two complex numbers with the same real and imaginary terms, but one's adding, one's subtracting. Now, the complex conjugates, if you were to add them together or to multiply them together, you will always get a real number. Like 5 minus I and 5 plus I. There we go, fix that. Or negative 6 plus 2i and negative 6 minus 2i. those are complex conjugates, and if you were to add them or multiply them, you would get a real number. Now, dividing complex numbers is going to depend on what your denominator is. If your denominator is a monomial, you're going to multiply your top and your bottom value by I. Now, you have to do it to both the top and the bottom, because basically we're multiplying by a value of 1. Any number divided by itself is just 1. So we're not going to change the value of the original number, just how it looks. So when I multiply the top, I get 10i, and the bottom gives me negative 2i squared. Then when you simplify, 10i cannot be simplified. I'm just going to copy that down. But I squared is equal to negative 1. So negative 2 times negative 1 gives me positive 2. But I'm still not quite done, because 10 is divisible by 2 and gives me 5i. The method still applies, this multiply top and bottom by I, even if your bottom and even if your top number is a binomial. So I'm still going to multiply the top and bottom by I, which gives me 28i here minus 8i squared and 4i squared on the bottom. So now I'm going to simplify the I squareds, which gives me on this one positive 8 plus 28i. Remember again, I squared is negative 1, so negative 8 times negative 1 gives me positive 8. And on the bottom, 4i squared is equal to negative 4. One more thing, everything here is divisible by negative 4. So I'm going to divide each number by negative 4 to get negative 2 minus 7i, and that's my final answer. Now, if your denominator is a binomial, you have to multiply the top and the bottom by the conjugate of the denominator, because remember that multiplying by a conjugate gives you a real number. And the reason we're doing we did multiply by I up here, multiplying by the conjugate down here, is you cannot have an I, you cannot have an imaginary number on the denominator. So on this one, I'm going to multiply by 5 plus I on the top and the bottom. So for the top, I'm going to distribute the negative 2 to get negative 10 minus 2i. On the bottom, I'm going to FOIL. First, outside, inside, and last. And then you simplify. The top can't be simplified, so I'm just going to rewrite it. On the bottom, 5i and negative 5i add to 0, so they cancel out. So what I have on the bottom is now 25 minus negative 1, because I squared is negative 1, which means I'm really just adding 1 to get 26. Last step, everything is divisible by 2, so I divide everything by 2. Now, if your top and bottom are both binomials, you still are going to multiply by the conjugate of just the denominator. You're just going to have to FOIL on top and on bottom, or use the box method if you prefer. So on the top, if I multiply, I'm going to get 14 minus 7i plus 6i minus 3i squared. And on the bottom, I'm going to get 4 minus 2i plus 2i minus I squared. And now I'm going to reduce. So 14 minus I plus 3, and 4, these cancel, plus 1. So 14 plus 3 gives me 17 minus I over 5, and I cannot divide these by any number other than 1, so that is my final answer. Alright, so that was a quick tutorial over complex numbers. I will see you next time.